Dear students, today I am going to teach you 80286 internal architecture. Before we start the architecture, there are a few basics that you need to know. I am sure you have learned the introduction video on 80286. Let me draw 80286. Eight zero two eight six is a 16-bit microprocessor, means it can transfer 16 bit of data at a time. Again, it has an ALU of 16 bit. So every activity that 80286 does is capable of working on 16 bit of data in one cycle. The diagram shows the internal architecture of 80286. Unlike 8086, 80286 has 4 processing units. 8086 has only 2 processing units, namely the bus interface unit and the execution unit, whereas 80286 has 4 separate units, and they are the address unit, the bus interface unit, the instruction unit, and the execution unit. All these 4 units work simultaneously. That is, their execution is simultaneous in nature. Now let's see each processing unit in detail. It should be kept in mind that the job of any microprocessor, whether it is 8086 or 80286 or 386, Pentium, and other higher processor, its job is to fetch, decode, and execute the instructions which are stored in the memory. Now, let's see the first unit, which is the address unit. This unit computes the physical address of instructions and data that CPU wants access to. In real mode, address unit computes address using the base address and offset address similar to 8086. As you know, in 8086 we have calculated physical address as segment address into 10 plus the offset address. Thus, it can access 1 megabyte of memory. In protected mode, the processor uses all 24 bits so that it can access 16 megabyte of physical memory and 1 gigabyte of virtual memory. As you can see here, in this processing unit, there are various blocks. The physical address adder uses the 20-bit or 24-bit physical address depending on the mode in which the microprocessor is operating. The input to this physical address adder are the offset adder and the segment bases. Segment base is nothing but the address of the segments in the memory. The offset address is the output of offset adder. The segment limit checker checks so that the current offset address does not exceed the segment size, that is 64 kilobyte. Thus, using segment base and offset address, the physical address is calculated. So, it gives output either 20-bit physical address or 24-bit physical address depending on the mode the processor is working. The next unit is the bus interface unit. The bus interface unit performs the same operation as the bus interface unit of 8086 microprocessor. This unit acts as an interface with the outside world for this microprocessor. This unit performs all the memory read and write or IO read or write operation. It prefetches the instruction bytes and stores this in queue. It also controls the transfer of data to inform processor extension device such as 80287. As you can see here, this block contains the address latches and drivers, which contains 20 or 24-bit physical address. It has got 24 address lines from A0 to A23. It also generates two control signals, BHE bar, memory M/IO, that is memory or input output bar. The prefetcher unit works for the purpose of storing the instruction in the 6-byte prefetch queue beforehand. The processor extension interface is useful for interfacing the coprocessor with this microprocessor. The bus control logic generates control signals. Whatever data that is input from random access memory is available to D0 to D15 data lines and enters microprocessor via data transceiver. Then the instructions are stored in 6-byte prefetch queue. Now we will see the instruction unit. The instruction unit receives arranged instructions from 6-byte prefetch queue. The instruction decoder decodes up to 3 prefetch instructions, and these instructions are stored in 3 decoded instruction queue. From these prefetched instructions are taken by the execution unit. Now let's see the execution unit. The execution unit is exactly same as the execution unit of 80286 microprocessor. This unit executes the instructions that it receives from the instructions unit. In real mode, this unit has the same set of register as that of 8086 except one 16-bit register. As you can see here, there are mainly 3 blocks in execution unit such as ALU, general purpose registers and control registers. The instructions that are fetched from the execution unit goes to the ALU and ALU performs the following instructions, and the result of the operations are stored in the registers. Now let's understand the whole process in a nutshell. Physical address of the memory from where the instruction has to be fetched is calculated by using the physical address adder in address unit. Then the address is stored in address latches and drivers, which is a part of bus interface unit. After that, via the data bus, instructions is fetched from the memory. This instructions is stored in 6-byte prefetch queue. It should be kept in mind that the next instruction is stored in the queue. Then it goes to the instruction decoder in instruction unit. The instruction decoder converts the opcode that it receives from the memory into assembly language. Suppose the instruction is 01010001, which represents BA at BL, CL. Here 01010001 is symbolic. The instruction queue converts 01010001 into add BL, CL. That instruction is received by the ALU. The ALU adds two registers BL and CL and stores it in BL. Suppose BL contains 3 and CL contains 4. Then we have to add 3 plus 4, which is 7, and store it in BL. In this way, 80286 carries out the operation. I hope you enjoyed the video.